This is the intro video for AP Calculus BC, section 5.3, and you can see here that we are going to be looking at derivatives of inverse functions. And so before we get too far into this, let's look at some properties of inverse functions and talk about what they are a little bit. So in their most basic sense, inverse functions are functions that undo each other. Whatever one function does, the other one completely undoes it. And so from that kind of basic understanding, maybe this next property will make sense. So if G and F are inverses, so if we're presupposing that, then if we do a composition of functions, f of g of x or g of f of x, in both cases, if we do that composition, we'll get the same answer, and that answer is x. This is because G and F are stripping away what the other one does, and you're simply left with the input. So that's a very important property, and we'll use that coming up here. One other property, if we have two functions that are inverses, then we could say that the inputs and outputs are switched. The inputs and the outputs are exchanged. So we're going to do a little exercise with this. This will be probably the only time that we can actually, at least with what we're doing, that we can actually find the inverse. We're going to do that though. So we're going to find the inverse of f. Let's do that first. If you remember, the way that you do that is you take your x's and your y's and you switch them around. So I would rewrite this as x equals y cubed plus 1, and then you solve for y. So x minus 1 equals y cubed, and then you would cube root both sides and get y equals the cube root of x minus 1. Okay, so now we're going to go and we're going to do the next thing that we're asked to do, and that is label that inverse g. So I'll do that. And we're going to create a table of values for both f and g. So I'm going to write x right here, and I'm going to write y equals f of x. And we'll do kind of the usual typical inputs, -1, 0, 1, and 2. And I'm going to be using f this time, so that's my f function right there. So when I plug in a -1, I should get 0. If I plug in a 0, I'll get 1. Plugging in a 1, I'll get 2. Plugging in a 2, I will get 9. All right, now I'm going to do the exact same thing, except I'm going to do it for the g function. I'll do that over here. One little difference, though, is I'm not going to be quite so random about my inputs. I'm going to make my inputs for this g function the outputs of what I used, or what I got for the f function. So I'm going to plug in a 0, 1, 2, and a 9. I'm getting those numbers from this list over here. Okay, and of course we're going to be using the g function this time. Okay, so if I plug in a 0, 0 minus 1 is -1, and the cube root of -1 is -1. You plug in a 1, 1 minus 1 is 0, the cube root of 0 is 0. You plug in a 2, 2 minus 1 is 1, cube root of 1 is 1. Hopefully you're seeing this pattern here. Finally, when you plug in a 9, 9 minus 1 is 8, and the cube root of 8 is 2. So hopefully what you can see here is that the outputs for g of x perfectly match the inputs for f of x. And so this is a really important property that we will use coming up here, where basically we're trying to illustrate here that the inputs and the outputs get switched around. Okay, so we're going to do one example here together to finish out our video. Okay, so for a problem like this, and this will be typical of most of the questions, we're not going to be able to find the inverse. And let me illustrate why. If I were to take this f of x function and say, y equals 1/4 x cubed plus x minus 1, and say, all right, well, I'm going to switch my x's and my y's. I'd get x is equal to 1/4 y cubed plus y minus 1, and now we're supposed to solve for y, and I think that you're going to find solving for y is going to be the issue. I don't think it's going to go very well. I don't think it's going to be possible for us. And so for that reason, we will still use the properties we looked at before, and they're going to be the main thing that we're going to use. We're just not going to be able to easily or possibly find the explicit function for the inverse. So here's what we're going to do. We are going to develop a little formula, and I hope that you choose to memorize this formula, and I think over time, if you use it enough, you'll just sort of naturally memorize it. But here's how we do this. So we're going to derive the formula for the derivative of the inverse. And I am going to define the inverse of f as g. This just makes the notation quite a bit easier. So I suggest that you do the same thing. I'll show you why here. So we're going to start off with this property that we looked at earlier. If f and g truly are inverse functions, then their composition will always give you x. Now let's remember that we are defining the inverse of f to be g, and it wants to know, the question wants to know, what is the derivative of the inverse of f? So they're really asking for g prime, and specifically g prime of 3. So we're going to try to find a formula for g prime of x first, then we can plug in the 3 and get all the numbers straight. So here's going to be our formula. We're looking for derivatives, and so what I'm going to start off by doing here is differentiating this equation that I have. So I'm going to have to use the chain rule to do this. It's going to give me f prime of g of x times the derivative of the inside, and the derivative of x, of course, with respect to x at least, is 1. Remember, we were looking for g prime of 3, and so this g prime of x really is what we're going to be trying to find. So to finish this formula out, all we really have to do is divide. So g prime of x is equal to 1 over f prime of g of x. Okay, so that's the formula right there. Suggest you memorize that or use it enough to the point where you do get it memorized. Definitely a useful formula. Okay, so if I know g prime of x, I can then plug in a 3 for x and get what I want. So g prime of 3 is equal to 1 over f prime of g of 3. And here's where we run into some issues, fixable issues nonetheless, but issues. So g of 3, like if we had a g function, all we'd do is plug a 3 in for x and it'd be over very quickly. But we don't have a g function, and we've already kind of looked at earlier, like, we can't get one, we can't find one. And so we're going to have to use that other property of inverses, the property that the inputs and the outputs get switched. So since g is the inverse of f, and we're trying to input a 3 into g, here would be the property. An input for g is the same thing as an output for f. An input for g would be an output for f. It would be the same thing. So I do have an f function, of course, right here, and so I'm going to do that. So instead of plugging a 3 in for x in g, I'm going to plug a 3 in for the y, or the output in f. So it'll look like this. 3 equals 1/4 x cubed plus x minus 1. All right, so to solve this, we're going to have to do some educated guess and check. I know that's very rare, but we're going to do that. Numbers are going to always be pretty small, somewhere around 0, 1, 2, 3, somewhere in there. And I think the one that works here is 2. I think if you plug in a 2, you'll see that that works. Okay, so x equals 2. So we're going to write g prime of 3 equals 1 over f prime. We just found out that g of 3 is 2, so I'm just going to put 2. So my final step then would be to find f prime. That is something we can find. So f prime is equal to 3/4 x squared plus 1. We then plug a 2 into that. So I think that's going to end up being a total of 4. So g prime of 3 would equal 1/4. Okay, so again, big takeaways. Make sure you have this formula memorized or used enough to the point where it's memorized. And then keep in mind the important property that with inverse functions, the inputs and the outputs get switched. All right, hope that helped. See you in class.